Welcome to The Explainer. Today we're diving into a real cosmic whodunit, a case of mistaken identity happening right at the edge of our own solar system. You know, for decades, pretty much ever since we got our first and only glimpse of them up close, we've had this really neat and tidy label for these two distant blue worlds. We call them our solar system's ice giants, a pair of twins, basically, defined by one simple idea. But what if that story was wrong? See, that neat little label, it's starting to fall apart. There's a whole wave of new evidence coming from modern computer models, and it's forcing scientists to ask this really startling question, one that could totally rewrite the textbooks on how planets are even made. All right, so let's get into it. To really understand what's going on, we first have to look at the story we've been telling for years, the identity that has defined these planets for a whole generation. So the classic story goes like this. Uranus and Neptune are ice giants, and this whole idea was based on a pretty simple concept about how solar systems form, right? Way out there, far from the sun, it's super cold. So cold that things like water and ammonia freeze solid. And those frozen bits, well, they're the perfect building blocks for icy planets. And from that idea, scientists built this textbook three-layer model. It was a really clean picture. You've got a small rocky core at the center, then this massive middle layer of hot, dense fluids we call ices, and then a thick atmosphere wrapped around the whole thing. The problem is, this entire model was built on an incredibly fragile foundation of data. I mean, think about this. Our entire up-close understanding of these two enormous worlds comes from just one spacecraft, Voyager 2, making a super-fast flyby back in the 80s. We're talking about 1970s technology making some frantic observations as it just zipped on by. And here's where the case starts to get interesting. As scientists started looking at that old data again, but with new, much more sophisticated tools, some really unsettling clues started to pop up. Things that just didn't fit into that simple ice giant box. The real kicker here is this thing called compositional degeneracy. It's a frustrating problem. It means that with the very limited data we have, a whole bunch of different internal recipes could all look the same from the outside. It's kind of like trying to figure out what's in a cake just by looking at the frosting. An interior that's mostly rock could explain what we see just as well as one that's mostly ice. And this wasn't just a theory. There were some really weird clues backing it up. For one, both planets have these bizarre magnetic fields that are just wonky. They're wildly tilted and way off center. And then there's this huge thermal paradox. Neptune is glowing with internal heat, but Uranus? It's mysteriously cold. It gives off almost no extra energy at all. What's up with that? So what does all this mean? The big takeaway from these clues is that the insides of these planets probably aren't just some well-mixed, slushy ball. Instead, they're likely layered and separated, kind of like oil and water. This internal layering, that could be the key to explaining those wacky magnetic fields, and it might be what's trapping all of Uranus's ancient heat, keeping it from escaping. So you've got this ambiguity, you've got these strange clues, and all of it just blew the case wide open. It made room for a brand new suspect in our cosmic whodunit, a completely new identity that might actually fit the evidence a whole lot better. So what is it? Well, could Uranus and Neptune actually be the solar system's first rocky giants? Modern computer models, the ones that aren't tied to those old assumptions, they've shown it's totally possible these planets are dominated not by ice, but by rock. In fact, that idea lines up way better with how we now think planets form, suggesting that the building blocks out there were probably loaded with rocky stuff. And this isn't just about our backyard, Planets the size are the most common type we see out there in the galaxy. So this really lays it all out, the two competing ideas for what's hiding deep beneath those clouds. On one side, you have the classic, comfortable, ice-rich model. But on the other, you have this new, rock-dominated model, and if it's true, it could completely change how we think about the history of our entire solar system. And here's a twist. They might not even be identical twins. The crucial point here is that recent studies, like one from Vanessa Ramirez and her team, suggest Neptune is way more rock-enriched. At the same time, Uranus seems to need a lot more ice to make the numbers work. This hints that these two twins might have had two very different upbringings. Okay, so if we have a new suspect, right, a really compelling alternative theory, then why can't we just solve the case? Why has this mystery just been hanging around for decades? Well, the simple answer is we're trying to solve a 21st century mystery with 1970s evidence. That one quick flyby just didn't give us the kind of detailed proofs we need to tell these two suspects apart. And honestly, the challenges of going back are just immense.
I mean, just for starters, think about the travel time. A new mission launched today, it wouldn't even get to Uranus for at least 12 years. The team that designed the thing could literally be retired by the time it starts its main science mission.
And then there's the distance. We're talking about a colossal 4.5 billion kilometers away. At that point, the sun is just another bright star in the sky. So solar power? Useless. You need a nuclear power source. And trying to talk to the spacecraft? You send a command and then you wait for hours just to get a reply. And those monumental challenges, the time, the distance, that's exactly why this case has gone cold. Since 1989, nothing. For over 30 years, our understanding has basically been stalled, just waiting for the technology and, frankly, the political will to make that long journey back.
All right, so how do we fix this? How does the scientific community plan to finally get the evidence it needs to crack this case wide open for good? The solution, and it's the top priority for planetary scientists right now, is a brand new, dedicated mission, the Uranus Orbiter and Probe. And its goals are crystal clear. First, use a long-term orbiter to map the planet's gravity with insane precision. Second, drop a probe right into the atmosphere to taste its chemistry directly. And third, explore that whole fascinating system of moons, because some of them might even be hiding oceans. And the scientific case for going back is it's compelling. As the physicist Brian Cox puts it, the argument for a dedicated orbiter mission is simply overwhelming. Because the discoveries we could make, they'd be revolutionary. Because right now, without that new data, we're just stuck with what researchers call a plurality of models. We can make theories, we can run simulations all day long, but we can't actually know the truth. The key evidence we need is still out there, just waiting for us to go and get it. And you know why this matters so much? Because planets the size of Uranus and Neptune, they're the most common type we've found orbiting other stars in the entire galaxy. So solving this identity crisis in our own backyard is absolutely essential to understanding literally thousands of other worlds. It leaves us with one last big question. What if both of our labels, ice giant, rock giant, are just too simple? Maybe the real answer is a whole new class of planet we haven't even thought of yet, forcing us to rethink not just two worlds, but an entire category of planet that fills the cosmos.